Safety Toolbox Talk number 341. Types of inerting, ensuring safety and efficiency. In the process industry, various types of inerting processes are used to ensure safety, prevent accidents, and maintain the quality and integrity of materials. Below are the most common types of inerting processes employed in different industrial settings. 1. Continuous inerting. Description: continuous inerting involves the continuous flow of inert gas, usually nitrogen or argon, into a system to maintain an inert atmosphere. This process is used when it is necessary to keep the environment free from reactive gases such as oxygen, throughout the duration of operation. Applications: chemical reactors, storage tanks for volatile chemicals, pipelines carrying flammable or reactive substances. Example: nitrogen is continuously introduced into a reactor to prevent oxygen from reacting with sensitive chemicals. Two. Batch inerting. Description: batch inerting is a one-time application where an inert gas is introduced into a system to replace oxygen and other reactive gases during a particular process, often during startup or maintenance. Applications: during maintenance of reactors, storage vessels, or pipelines. When loading or unloading sensitive materials. Example: before the start of a chemical reaction, nitrogen is introduced into a reactor to inert the system for a specific batch process. Three. Purge and sweep inerting. Description: purge and sweep inerting involves introducing inert gas into a system to displace oxygen and other reactive gases. The inert gas is allowed to sweep out the oxygen, ensuring that the system is filled with an inert atmosphere. This process is typically followed by the removal of excess gas from the system. Applications: storage tanks, pipelines and transfer lines. Example: a storage tank is purged with nitrogen to remove oxygen before filling it with flammable liquids. Four. Blanketing, headspace inerting. Description: blanketing involves creating a protective layer, blanket, of inert gas over a substance to prevent contact with air, oxygen, and moisture. It helps prevent oxidation and degradation, particularly in sensitive chemicals or materials. Applications: storage tanks containing volatile chemicals, oils, or solvents. Tanks used in the food and beverage industry. Example: a storage tank containing a volatile liquid is blanketed with nitrogen to prevent the formation of flammable mixtures with air. Five. Pressure inerting. Description: pressure inerting involves maintaining a slight positive pressure of inert gas inside a system to prevent the ingress of oxygen or other contaminants. The inert gas is continuously supplied to keep the pressure higher than the surrounding atmosphere, ensuring that no air enters the system. Applications: sealed reactors or pipelines. Closed systems where constant inert conditions are required. Example: a chemical reactor is maintained at a positive nitrogen pressure to prevent oxygen from entering and reacting with the materials. Six. Inert gas flooding, or total flooding. Description: Inert gas flooding involves filling an enclosed space entirely with an inert gas to displace oxygen and ensure a non-reactive environment. This process is often used in emergency situations to prevent combustion or to extinguish fires. Applications: fire suppression systems in chemical plants or refineries. Enclosed storage or processing areas handling hazardous materials. Example: a fire in a chemical plant is suppressed by flooding the affected area with nitrogen to starve the fire of oxygen. #7. Displacement inerting. Description: displacement inerting involves replacing oxygen or other reactive gases with an inert gas by physically displacing the unwanted gases. This method ensures that the system or vessel is filled with an inert atmosphere, eliminating any risks of chemical reactions with oxygen. Applications: vessels, pipelines, and storage tanks where oxygen or moisture must be removed to avoid degradation or reaction. Example: a reaction vessel is displaced with nitrogen to ensure it is completely oxygen-free before introducing reactants. #8. Inerting for hazardous materials handling. Critical inerting. Description: critical inerting is applied to handle hazardous, flammable, or highly reactive materials that require stringent safety measures. In this process, inert gas is used in systems where hazardous chemicals could react violently with oxygen, moisture, or contaminants. Applications: handling pyrophoric materials or highly reactive chemicals. Used in laboratories, refineries, and chemical plants with critical materials. Example: pyrophoric chemicals are transferred in a nitrogen-filled atmosphere to prevent spontaneous ignition due to exposure to oxygen. Thank you.